surface charging, or high energy electrons which can embed themselves within the spacecraft and cause deep dielectric charging. Or it can be protons or galactic cosmic rays that cause single event upsets, and en masse, the lot of them, cause radiation damage to the solar panels and other systems. So it's very, very important for the satellite community to have the best, the most timely information that they can get. And that's the purpose of this activity, and I'm very happy to be here to participate in this. So I'll turn it back over to Dan for some concluding remarks.
Thank you very much, Joe. It's a delight to be able to tell you that we turned on our instruments and we saw fascinating new phenomena in the Earth's vicinity driven by solar disturbances. It's also a delight to be able to tell you that we are really able to do so much research with our basic research, astrophysical research, if you would say, in our local neighborhood. But it's wonderful to be part of a field where that research also has good practical applicability. And we know that the things that we're measuring now have the kind of relevance to society that Joe's spoken about. So we're delighted to try to answer any questions you may have today and to talk about this duality in our field, great basic research and also great applicability to societal needs. Thank you very much.
Okay, thank you, Dan, and thank you to all the panelists. We'll take questions now from media in the audience, on the phone lines, and then also from you all watching online. As a reminder, you can ask a question via Twitter by just using this hashtag, AskNASA. If you have a question in the audience, please get to one of the people with the microphones over here. We did receive a question or two before the briefing, so let me just throw that out to begin with. First question, what has this third Van Allen belt been doing since you first observed it last year?
Well, I can try to answer that question a bit. We saw this phenomenon for about 4 weeks. Then, as the data showed, and as Nikki remarked on as well, it was cut off like a knife edge. It disappeared. There was a rebuilding of the Van Allen belts also in a very abrupt fashion on about the 9th or 10th of October. But since that time, we've not seen a recurrence of the third belt. We're watching with eagle eyes to see if there is a resurgence of this. But so far in the last 5 months, there really hasn't been a recurrence of that.
Okay, and I guess we have some questions already via Twitter.
Yes, I read that CRES saw a third ring in 1990, and solar activity in 1998 made a brief third ring. Is this really the first time we've seen a third ring?
The CRES was the mission that was mentioned back in 1991, and that showed a new population of particles injected into much deeper into the magnetosphere, into more or less the inner zone and slot region. This is the first time that reported in the literature that one has really seen embedded in this outer part of the Van Allen zone the storage kind of phenomenon. And so we believe that this is fundamentally different than what's been reported in previous kind of observations back in the past.
Okay, is another question from Twitter?
Yes. Which belt was actually new? Was the original outer belt, did it shrink back into a storage ring and then a new belt form outside of that?
Well, let me again try. We're still trying to piece together exactly what happened, but yes, it seems as though an entire outer Van Allen belt acceleration event occurred, and then part of it was sort of ripped away, was torn away from the outermost part, leaving the storage ring, and that's what persisted, so immune apparently to external forcing for the next 4 weeks. And so what we were really seeing was that the storage ring was the remnant of an earlier acceleration event due to the kind of solar drivers that Mona and Nikki talked about.
Let me add to that also, if I may. This is still early days, and so we don't completely understand this phenomena that we're seeing. We're modeling it now. We're trying to develop the understanding. We're looking, as Nikki mentioned earlier, at the wave instruments, because they are likely one of the drivers, the waves that are generated. And it's all driven by the sun, but then there are internal waves that are generated as well. We're trying to piece this all together right now, and stay tuned. We will know more.
That's really what's exciting about new observations, is that when you know you've done something right observationally, when theoreticians say, well, that doesn't look right, we've got to go back to the drawing board here.
Okay, and one other question from Twitter before we go to the media.
A two-pronged question. What does the third ring mean for astronauts and satellites? And also, what impact will it have, if any, on the Earth?
Well, we might let Joe take part of that question. Joe.
Yeah, I think it probably will have little impact on astronauts and satellites, given the characteristics. But I would hurry up to say that there's still a lot that we don't know, and we can talk about space operations of today, but also there's operations in the future that are planned. So I think probably the true answer to the question is still to be known.
And if you remember the picture that I showed during my presentation, the International Space Station is down below the inner belt. This new ring is actually much further out than that. It's at about 12,000 miles above the surface, so it's much higher than astronauts go. Now, if we send another mission to the moon or to Mars, then we would have to pass through the region. But we've done that before, too. In the past with Apollo, we passed through pretty quickly. So, but in realistic terms, it's not going to affect our astronauts, certainly not on the space station.
Okay, another.
But having said that, the regions that we're looking at with the third belt are magnetically connected to the altitudes that the space station is orbiting on. So while there's no direct impact, there are still going to be effects that are seen, and I think that just understanding more about the outer radiation belt, its structure and its dynamics are very important for enabling us to have better models, better prediction models, do a better job of predicting the lifetime of spacecraft, just by knowing that it's way more dynamic than we had even expected prior to the launch.
I'd like to jump in on this and just say, too, that we're fortunate that nature performed an active experiment for us that really gave us this very kind of discrete onset and then a very discrete end to this particular three-belt phenomenon. And this is going to teach us a lot about how effectively the magnetosphere can store and maintain an electron population for extended periods of time. And by doing that, I think it's going to greatly help us greatly increase our understanding of just how this complex accelerator that Nikki talked about really operates.
Okay, our next question.
Do you have an estimate of how the total energy content of the three, then two belts changed during the process?
Let me first say that I want to emphasize what Mona said, too, which is that we're just studying these things now. Many of the questions that are being asked are exactly in our minds, and we're going to try to more quantitatively address those. So this is relatively early in the mission. We're trying to piece together what happened, why did it happen, and what are the implications for such things as total energy content.
Okay, our next question, still from Twitter.
How did this radiation belt go undetected for so long?
We've never had the capability and the outstanding technology that we have with the radiation belt storm probes, the Van Allen probes, I'm sorry. It is a mission that is designed to go after the dynamics and the structure of the radiation belts. We're carrying the right instruments and we're in the right orbit to be able to do that. And I think the fact that we've had such an amazing discovery within days of turning on the instruments is really proving just how spectacular the science from the Van Allen probes will be.
I like to quote America's most notable philosopher, Yogi Berra, who said you can observe a lot just by looking. And I believe that when you open new eyes on the universe, you invariably see new things. And so I think that's where we find ourselves now.
Okay, our next question, please.
Question for Joe Conscious. What can operators and companies do in order to protect their satellites once they have the predictions?
Well, that's a good question, because it depends a lot on the particulars of the mission and what they're trying to do. But I can give you an example from the past. In 2006, the EUMETSAT, the European Meteorological Satellite Organization, launched a satellite called METOP. And METHOP had on board 2 high-rate transmitters to send down broadcast direct TV-like imagery of the weather, and they really wanted to do it over northern Europe. Shortly after the launch, they found that one of their transmitters quickly failed. And fortunately, they had a backup on board. But before they turned the backup on, they wanted to figure out what the problem was in terms of the environment or exactly what. So they went back to the engineering lab and they found out that this particular piece of equipment had a susceptibility to charged particles that had a prevalence in the auroral zone and in the South Atlantic anomaly. So when they turned the backup transmitter on, they then organized or created a procedure through which they turn it off as it flies through the auroral zones, and they also turn it off when it flies through the South Atlantic anomaly, but then they turn it on the rest of the time. And in particular, they're able to capture the weather imagery from Europe, which at times is right on the edge between the auroral zone and the safe places. So depending on the kinds of activities and the particulars of the spacecraft, there are things that can be done to respond to the current state of the space weather. I don't want to say that every satellite works like this. There's a little bit of the 3 little pigs philosophy in building satellites. You can build your satellite out of bricks and you don't have to worry about anything. Well, that can be costly and heavy, and maybe you wouldn't be able to get the payload that you'd want at every point. So to then go to the less robust state, you may have to drive it a little bit, and many satellite operators will do that. They will reschedule command sequences. They will do the things that are at their disposal to account for harsh radiation conditions that can occur from time to time.
Okay, our next question, please.
Dr. Baker, could you briefly describe any innovations that improved the sensitivity and capability of the REP device?
Yes, we tried to build with detectors that were more stable and more sensitive to charge deposition from the detected particles. We tried to build much faster electronics so we could avoid traditional problems of pileup and dead time and other such effects. But we really were primarily focused on being able to do a better job of resolving to a high precision the energy spectra at these higher energies. Many previous measurements have sort of just made very broad brush kind of measurements at the higher energies, and without the kind of energy resolution that we were able to achieve with the REPT instrument, I think we would have again probably sort of smooshed all this out, and we wouldn't have really seen so clearly at all that we had these kind of distinct spatial and temporal features.
Okay, next question, please.
Are the collapse of the outer belt and its re-energization connected with any external phenomena that you can identify?
Yes, I think all of us in a way have addressed that, but we see very clearly, and maybe more clearly than we ever imagined we could with the Living with a Star program. We're able to watch the ultimate driver, the sun. We can watch these things propagate through the interplanetary medium. We can then observe directly the effects with the radiation belt storm probes, the consequences in the radiation belt. So we're in an enviable time here where we can really watch cause and effect play out before our eyes. Maybe Mona or Nikki would like to comment.
We have seen in the past, when we've had coronal mass ejections, we have seen a drainage and then a repopulation of the belts. We've seen that before. That's pretty well established. What we haven't seen before is those from the original particles in the outer belt coming in and forming this storage ring or this extra area and then lasting for a month. That we've never seen before. But we pretty well understand, at least at some level, the process that happens to drain the belts originally and then refill them.
But the fact that very similar solar drivers can have such a different effect on the radiation belts is really the central focus of the Van Allen probes. Just, sometimes it does bring up the radiation belts and other times it just annihilates them, as you saw in the plots that Dan had. And I think that, now we've got the ability to really bring those outer belts into focus, as Dan said, with the new technology. What we saw before as kind of a fuzzy image, we're now seeing with great clarity.
I think since we're talking in fairy tales, the three little pigs, well, we can also talk about Goldilocks. and having the sort of the right intense enough but not too intense, so you don't completely eradicate the outer Van Allen belt, but you eradicate a portion of it. I don't think we'd really suspected before that there could be this kind of Goldilocks event that would lead to this storage ring phenomenon.
Okay, next question.
Could the probes themselves affect the radiation belts, for instance, by generating waves?